you want to read it?
Sure. We destroy every proud obstacle that keeps people from knowing God. We capture their rebellious thoughts and teach them to obey Christ.
All right. Very good.
We destroy.
That's the point.
In a nice, gentle way, right?
It's
Your
gentle
argument
destruction.
is
We break-
destroyed.
So we were in the middle of answering this guy's videos.
This guy.
This
guy who
poorly
pretends that he has
drawn
big
guy.
muscles.
This
Yeah.
guy.
His big
Buff
muscles.
guy.
Yeah, this really buff guy. Oh, I saw a picture of him.
What's
He's
that?
not buff.
He's not
He's like, I need to go look what this guy looks like.
His spaghetti arms were a thing.
Let me guess. Let me guess.
Have you ever heard the word spaghetti arms? Yeah, that's.
Let me guess. He doesn't even have blonde hair, right?
All right,
No,
can you guys see the
spaghetti
screen
arms.
at home? Brandon or Joanna, can you guys see the screen?
You turned off your mic for like a second, but we didn't hear
Too
it.
fast.
Yes. Just say yes.
Thumbs up, something?
Yes.
Give a reaction.
Okay.
I
Good
think
class.
her thing is highlighted in green.
Yeah.
We got it. The
Can I
thumbs
get
up
an amen?
signature.
All right.
Again.
All right. So let's just jump into this today because I kind of want to get through this.
It goes like this. Whatever begins to exist has a cause. The universe began to exist. Therefore,
We've got through.
Interesting. Yeah.
If we're going to
We'll jump
evaluate,
ahead.
We were over halfway.
Yeah. Because we got past the part where you skipped the one important part.
You
skipped the whole like multiverse.
Oh yeah, I think
Yeah.
we just started. We were about here, right?
Yeah.
Right. So he skips
and
over the
doesn't
multiverse.
pretend that it's the same as the cosmos. We can skip that part and all just
Wait.
Well, that was it, right?
Yeah,
This
it's
even
right
applies to the multiverse.
Yep.
Whoop.
He's
Skip
skips.
wait.
first let's consider the second law
we'll
of
figure it out.
thermodynamics. It tells us the universe is slowly running out of usable energy.
We're going to want to talk about the first law of thermodynamics. So it's good that Craig affirms the second law.
Yes, we are.
Carry on.
It's quite plausible then that both premises of the argument are true. This means that the conclusion is also true. The universe has a cause.
Right. The argument concludes that the universe has a sufficient cause. Still no discussion of God, and the video is almost over.
And since the universe can't cause itself,
Okay, let's go back and
Oh my
review.
goodness.
What were the two types of causes that I talked about last week?
What was it?
No, we
So like even like this book, right?
Oh.
Oh yeah.
It's the
Physical and or material and
There's a material cause
and immaterial. Or
and
I don't know.
It's just
so like I could do a chemical analysis of this and tell you all about everything that's composed of and stuff.
Wow.
But it doesn't really tell you what
what
this
the words
means.
say, yeah.
Yeah.
So like we know it has a material cause and an efficient cause. So the efficient cause of the book is William Lane Craig and all the people that worked on publishing it. And Lee Strobel for the forward.
Nice.
Of
course.
All right. So again, that's part of the issue. If material is not eternal, and you want to say like the universe is not eternal and needs a cause, then the cause of the universe can't be material, can it? You need an efficient cause of the material of the universe that's immaterial. And so again, that's where he's gonna kind of try to inject here.
its cause must be beyond the space-time universe.
So far, so good.
It must be spaceless.
And now remember, they're saying since the universe can't cause itself, because remember what we talked, remember there's that $1 million word last week? Do you remember the $1 million word last week?
Was it infinite or something?
Mereological nihilism.
Oh,
yeah.
that.
Two words.
That very.
The word that you'll probably
No wonder I
never
wouldn't
use.
remember it.
You'll never use it again, ever.
It was on the tip of
But
my
you remember what
tongue.
mereological nihilism meant?
Is
Or at
it?
least how the guy tried to use it.
Let's see, Ian. That was
Yeah.
the whole column, not just the tip.
Oh, it's like when did the chair come together?
Right.
Yeah.
But then in reality, you're saying that the sugar never really
yeah.
came together.
It
'cause there's
doesn't
no
exist.
specified
We don't
material.
exist.
Right.
It's just the
because-
particles around
Yeah,
you
you're
in a
just saying
certain.
a real-
Right,
That's right.
but see, that's what he's going to go on to say about the universe. Like, well, the universe began in a way, but the parts that the universe came from were there before that. Maybe it was part of some other multiverse or universal ensemble of
And he
things.
already said that it
And
was
so-
cool that it was beyond the space-time universe, but then he has a problem. with
Right.
being
So
space.
again, you can't have it both ways, right? So if we're saying that we have good philosophical reasons to think that the universe is not eternal, and there's good scientific reason to think that the universe is not eternal, then if time, space, matter, and energy, remember he talked about universe and cosmos, but we're saying like it doesn't matter. You can talk about the universe, you can talk about the same thing applies to either or, right? Whether you have one universe or many universes, the problem is the same for, like, it has to begin somewhere, right? So then if that is not eternal, then it came into existence. And so that's why, like, remember matter, like this is made of material, and if matter exists, then by definition, what has to also exist? Space, because matter is in space, right? So.
Oh, we went over the rails right on the first one. Craig himself describes our universe as the space-time universe. The Big Bang was the start of our universe's local space coordinates, x, y, and z, and time, t. But just as a piece of graph paper has its own localized x, y spatial coordinate system,
Yeah, we
that
talked
piece of
about this
paper still
already, right?
exists in the universe's three-dimensional space. The cosmos may well have its own spatial dimensions. It may have many more dimensions than our four, or perhaps it could have even 0 dimensions. The point is, there could be
You are
any
getting
number of
sleepy.
sufficient causes in our universe that exist in some semblance of space
Oops.
outside of our version of it. The cause needn't be spaceless.
Timeless?
What applied to the 3 dimensions of space equally applies to the 4th dimension of time. A stopwatch has its own temporal system, but the one pressing the start button still exists in their own temporal system. The cosmos may have its own system of time, or it may exist in such a state that the idea of time is incoherent.
But again, the point that we said is that from the same philosophical argument, it doesn't matter, like I said, I erased it, sorry. If you have like time 1 and then hyper time 2 and hyper time 3, it's irrelevant because either way, time is a measure of change. And if we're talking about getting to today, there can't be an infinite amount of time before, whether it's like our version of time or a different measure of time, or however you want to measure the time, that's irrelevant. Either way, there's a series of changes and events that happen to get to today, but that series can't go back forever. There had to be a beginning of it, right? So again, that's kind of missing the point.
Don't yet know what the sufficient cause of the universe was, but it could easily have been temporal.
Immaterial?
This is getting repetitive, but there's no reason to assert that the cause couldn't have been a material manifestation. Scientists don't think that the Big Bang was from nothing, but rather the expansion of a singularity containing all of our universe's matter and energy.
And again, it goes back to the singularity only because that's when everything breaks down and they can't compute anything beyond that. So like, that's kind of like the boundary of what we can know. But again, it does nothing to dispute the argument.
Whatever was happening inside that singularity would certainly have been material as we know it. Earlier, Craig appealed to the second law of
Okay, so
thermodynamics.
this is all
But
new.
let's talk about the first law. Energy can be transformed, but it cannot be created nor destroyed. If this law holds, we need not appeal to a god to deal with infinite regress. Our eternal constant is energy.
Wow, that's
This seaside verbo is about to play host to an unforgettable vacation memory.
Where you are in the US, so they're probably getting 8 cents for this ad right now.
If energy has always existed, then it follows naturally that any existing universes could be a mere transformation of part of that energy. This is my personal cosmology, that if something has to exist eternally, that thing is energy. The advantage of choosing energy over positing an eternal God is that we all agree that energy is a real thing.
Uncaused?
The cause of our universe could easily have...
Okay, let's pause and talk about that. So remember, what was the second law of thermodynamics?
Process, something about
Everything will equalize, right?
Right, so
Yeah.
all the usable energy will dissipate, right? And so like, it will just be like the heat death of the universe, right? We'll just kind of like die out. And so that again implies like, well, that's weird because if we had been here forever, we should not have, like the sun should have burned out and all that sort of stuff. But here it is, like there's a lot of usable energy that's still in the universe. So it seems like it hasn't been here forever, right? And it's still just right for us to be here. And so he's saying, okay, the first law says that energy can neither be created nor destroyed. Is that true?
Yeah.
Yes.
Yeah,
No.
it's the first law.
I was thinking about what you had just said.
Right, sorry. But why is he wrong? Do you know this? I don't know if you guys studied any of this sort of stuff, like in school, physics class or whatever.
Wrong about what?
Why is he wrong about taking the first law of thermodynamics and applying it to the creation of the universe?
Well,
I'll give you a hint. You could do the same thing with the law of gravity. Like, the same thing would be true. In that, the law of gravity applies after the universe is created. Because it's describing the way things are in the system. Right? So the first law is essentially not saying that energy can never be created or destroyed ever, but it's in the system that we have, there's an amount of energy that never changes. Right? And the usable energy can change, but the amount of energy is just there. But that's within the system itself. But that has nothing to do with where the energy came from to begin with.
So
Right? So in other words, and I'll show you a video of this in a second, but so to say that you can never create new energy is just not true. Like if there was nothing, God could create it just like he created matter and time and space and all that. Like energy is part of that. But once you have the system, then you have the law of gravity, you have conservation of energy, you have the law of thermodynamics, all that stuff is in the system after the fact, right? Like that's the way this system operates. But it says nothing about that, you cannot, like there's no way for anybody ever to create any energy. Like, no, that's not at all what the first law says. What was your question?
but then any person with common sense would realize that nothing goes on forever without like something sustaining it. So like if the universe is slowly running out of usable energy and you can see that, like how does he believe that energy is eternal? Like energy is eternal, but you can't use energy forever.
Well, okay, don't confuse the first and the second law. So what you're talking about would be the second law, the usable energy. But the amount, so what some of these people will say is like there's the negative and there's the positive, and if you negative energy and positive energy, or negative mass and positive mass, or dark matter and all that sort of stuff. And I forget all the exact ways that they do it, but some of these guys will say if you balance it out, it's even on both sides. So the negative and the positive together equate to zero, so there's actually nothing. It's like, well, obviously that's not true. Here we are. Right, so let me show you this video. This hopefully will explain
Been a caused thing. Perhaps our universe was caused by a quantum fluctuation. 5D.
This notion that the components of the universe have always existed.
So a banana is part of a healthy diet when you're trying to lose weight, right? I know this might be a little hard to believe, but
I
it's
was gonna
not.
want to skip it.
See,
5 minutes later.
All signs point to the universe always existing, and therefore we don't need a God.
Yeah. What's funny about this objection is that this is not an objection to the existence of God. This would be an objection to the Big Bang theory of the origin of the universe. The universe is false because according to that theory, all matter and energy, even space and time themselves, came into being at the moment of the Big Bang. And and are therefore not eternal. They haven't always been there in the past. So if these fellows were right, all contemporary cosmologists who believe in the Big Bang theory of the origin of the universe would be contradicting the laws of thermodynamics, and that's hardly the case. Why? Well, because the laws of thermodynamics, in particular the law of the conservation of matter and energy,
which is the first law,
only applies once the universe comes into being. It applies at every moment, at every time, and every point in the universe. But it doesn't apply to the origin of the universe itself. And that's why cosmologists don't consider that the law of conservation of energy and mass is violated by the Big Bang theory of the origin of the universe. The law holds at every moment in the universe, but it doesn't say that the universe itself, all matter and energy, can't have an original beginning point at some point in the finite past. In fact, the atheist fellow mentioned the laws of thermodynamics. He might have wanted to talk about the second law of thermodynamics, which says that in a closed system, things tend toward increasing disorder. Now, the universe on the atheistic view is just a gigantic closed system because it is everything there is, and there's nothing outside it. And what that implies is that given sufficient time, everything in the universe would grind down to a state of maximum disorder. So if the universe has existed for infinite time from eternity past, why is it that we don't find ourselves in this sort of thermodynamically disordered state? I think that the best answer to that is that the universe has not existed forever. It began a finite time ago in a low entropy condition, and the thermodynamic clock has been running ever since then. So the evidence of thermodynamics itself suggests that the universe and matter and energy are not infinite or eternal in the past, but had an absolute beginning.
All right. So again, the point, one of the main things I want you to get out of this is, it's not like you have all these people on YouTube and everywhere else that make these types of videos, and it's kind of like, it's not like anything that he's saying hasn't, it's not like it's like, oh, I didn't think about that. You know, like, oh, you got me there. Like, no one knew about that. Really, what I hope you see is that this guy really is either misunderstanding the argument or the points, or just doesn't really quite have his facts correct, right? So like when he appeals to the first law, to have energy be eternal, and then eternal energy is the cause of the universe, it's like, well, that's not what the first law says, right? So again, that doesn't work.
I think that he just doesn't like the idea of God. So
was
he's
a-
doing, wait, listen.
Yeah, sorry.
So he's doing whatever he can to make other people not believe in God. Because obviously that other part that he skipped, like there's no way that he missed that.
Right.
Like he knew that and he intentionally skipped it. And the only thing behind that I can see is to mislead other people as well, because that means he's deflecting it as well. He doesn't have an answer.
Right.
So he's not putting it in the video.
Right. Why would you skip over the?
Yeah. So I think he
Also
literally
applies to
just doesn't want to believe it, even if he knows he's wrong.
Wasn't he like a former Christian?
Yeah.
Supposedly, that's what he says. Yeah. I've watched several of his videos, so he has a whole video about his whole story. We'll finish this up here.
End of a prior universe by the flapping of wings of a cosmic butterfly. The Kalam argues only for us.
Now again, there are, and that was addressed in the video too, right? There's been theory after theory of these kind of oscillating universes, or universes that expand and then they contract again, and then they expand again and they contract again, or, you know, the multiverse, that we're just one of a cosmic ensemble of an infinite number of universes and stuff, which again, we'll get into in the next chapter, which there's other problems with that too. But all these models have failed. Like they all keep running into these roadblocks where they're like, this doesn't work, this doesn't work, this doesn't work. And that's why when he goes back to what he quoted from the Gord Blanken thing about like any universe that's in a state of expansion can't be past time infinite. It has to have a beginning, and it applies to the multiverse. That that's a huge problem, right? I mean, for all these models, again, the idea is if there is, think about even this, the second law of thermodynamics, if it's a closed system, if the multiverse itself is a closed system, you have the same problem, right? So you can't just, it's like, think about if I take a basketball and I drop it, what happens? It bounces, and then it bounces, and it bounces, and it bounces, it bounces, and then it stops. It's the same kind of concept, right? The usable energy is going away. So like, how many times could the universe expand and contract and expand and contract? You can't do that infinitely, right? Because eventually you'll run out of the usable energy.
Well, if it had a sun, wouldn't it like burn up? Like, if it had
That's what I mean. Like that's the sun is just one star, but the whole idea is that all the stars eventually would burn out. Like it doesn't work.
Efficient cause of our particular universe. If something has to be uncaused, let's go with energy.
And unimaginably powerful.
One last time, the Kalam argues only for a sufficient cause. An avalanche can be caused by the slip of a single pebble. There's no...
Again, that's apples and oranges, because the avalanche is something impacting something else that already exists. But we're talking about going from nothing to something. So it's not like I went like that and all the snow came down the mountain. Like there's no mountain, there's no snow, there's no, not like where did the mountain and the snow come from, right?
No reason the cause of our universe needs to be anything more than adequate.
Much like God. The cosmological argument shows that, in fact, it is quite reasonable to believe that God does exist.
All the cosmological argument does is point toward a cause, but tells us nothing about that cause. When the argument is said and done, we are left asking, what caused the universe? Craig says God, and others more honestly say, we don't know. If you think that we don't know automatically equals God, then how is your thinking any different than those who decided that lightning came from Zeus? The only honest answer in all of this is something caused the universe, but we don't know what it was. The Kalam cosmological argument says nothing about God. If you enjoyed this,
all right.
No,
but
I
he's
did not enjoy this
Dislike.
at all.
No.
Yeah, no, wait, can you dislike it?
No, he's
It
not
won't
signed in.
recommend it to other people.
He's not
Report it.
signed in. He's not signed in on his account.
No,
so-
you know, he's so wrong. He just
Let's
said
copyright claim him.
how?
Yeah.
Because
People
he's
can just do
oh,
that.
because he's reacting to another video,
Yeah.
right?
Yeah.
So yeah, you
Like,
could
I
probably.
want to show you.
Let's cancel
Before we.
him.
Yes.
No, he has a little disclaimer at the beginning about copyright.
Oh.
I want to show you a little bit about this idea of the universe from nothing too, because and I mean, again, I said this at the beginning of this class. This is kind of like the city bus tour version of things. So like, certainly we're not doing a deep dive on any of these things. We're just kind of passing through it. It's like, oh, there's the Washington Memorial. Oh, there's the Lincoln Memorial. Like but we're not getting off the bus and going inside. Right? So it's the same thing here. There's tons and tons of stuff about all this stuff. If you're interested in like each of these chapters, you could spend years studying it.
Wait, you know, he just said he like didn't even give an answer. He said we don't know. Like at the end.
Well, that's the whole.
Or that's what he said. And then
He got
also,
on our case for believing that God was the thing.
Right.
And then he
He
said
was-
other people more honestly, but he said he believes in energy. So he's also.
Yeah. Well,
not being
that's
honest.
the whole, their whole thing is that, remember I said at the beginning, when we're talking about all this sort of thing, you have to always remember, like, for the people who are doing videos like that, do they have a positive case for what they're believing? Like, is there good evidence to show me that I should not believe the Bible? Is there good evidence to show me that I should be an atheist? Do you have any good evidence that would convince me? Or is it just like, my standard of proof is so high that no evidence that you give me will I accept? You know, like that's kind of what usually you deal with. Like, well, what do you do with all the evidence for the resurrection of Jesus? Well, we can't know because it happened 2,000 years ago. Well, there are eyewitnesses there. Well, like, unless I could talk to them in person, it's like, well, okay, like.
well, you can't
You
talk
can't talk to somebody that's 2,000. But even if you did, you'd be like, well, I still don't.
You can't
It's
talk
like,
to the soldiers in World War II, but World War II happened.
Right. Right, exactly. It's
Yeah.
the same idea. The
Did it
burden
happen?
of
Are you
proof is
sure
so
it
It
high.
didn't happen.
Do you have proof they could have all been hallucinating?
So anyway,
Yeah.
the point I wanted to make is,
Popularizers of modern science, like Lawrence Krauss.
I gotta say, this like sometimes if you just get close to it. This he did a 3-night debate with this guy Lawrence Krauss, who's a very smart guy. He's a genius when it comes to his field in physics and cosmology, but he's a very outspoken atheist and rather rude person. And if you watch the dialogues with Craig, they do 3 different nights in Australia, and they go round and round and round and round about all this sort of stuff. And Krauss wrote a book called A Universe of Nothing. And so he says that, yes, a universe can come from nothing, but his definition of nothing is not nothing, because nothing is no thing, right? There's no thing, that's it. But his is just like, if you take empty space, we would say that's nothing, but there's stuff in empty space. It's like, well, then
it's not nothing.
Not nothing. It's space with stuff in it, right? So that's
Which is what we are.
right. So that's what he's talking about. So
Love to say that in quantum mechanics, you have theories by which the universe comes into being out of nothing. And in fact, that's just not the case. You have a physical state of affairs, which is either a quantum vacuum, a field of fluctuating energy, or these are quantum physical fields described by physical laws. And these physical states of affairs can reconfigure themselves so as to produce particles or the universe. And so there definitely are causes in this case for the universe or the particles coming into being.
Yeah, Lawrence Krauss, his book, A Universe from Nothing, is a fantastic overview of cosmological science, but I hear this a lot of the time too. People say, well, you talk about something coming from nothing, but nothing isn't really nothing. And if that's the case, then we're not talking about the same thing here. I agree with you on that point.
Have you read the review in the New York Review of Books of Krauss's book, A Universe from Nothing?
I'm sure I did.
David Albert. The philosopher of quantum physics, David Albert, wrote a review of Krauss's book, and it just is excoriating for the sloppiness of Krauss's use of the term nothing.
I have read that review. I think I read it in preparation to talk to Lawrence Krauss, who I know follows me on Twitter. So I'll be careful what I say about him here and how much I agree with you on the sloppiness of his work. But yeah, it's worth bearing in mind that we're talking about 2 different things here, right? When a philosopher is talking about nothing, they mean, as Aristotle said, what rocks dream of. They mean nothing, right? And so if there's some kind of quantum soup or something, then that is not actually nothing. But
yeah, here's how I like to put it, Alex. Nothing, the word nothing, even though it's a pronoun, it's not a referring term.
Right.
It's not a singular term. It's a universal quantifier. It's a negative quantifier. It means not anything.
Yes.
So if I say I had nothing for lunch, that is saying I did not have anything for lunch.
Because if you don't make that careful distinction and you think of nothing as something that can be spoken about, you can make arguments like in A.C. Grayling's History of Philosophy, he puts forward the argument, nothing is brighter than the sun, a candle is brighter than nothing, therefore a candle is brighter than the sun, right? But clearly, the point being raised here is that when we talk about nothing, we have to be clear that, as you say, we're talking about a kind of existential qualifier. We're saying no thing, not the existence of nothing.
Universal quantifier. Yes, that's right.
Okay.
Yeah, which shows again the importance of philosophy of language
Yeah.
in dealing with even scientific issues.
Yeah.
all right. So that moves us on to the next chapter. Did you guys get a chance to read the next chapter, or anything up to this point that you want to talk about before we get on to design? We're moving right along. All right. No? Anything? Anything at home? All right, so the next chapter is about what's called the fine-tuning argument. And I just want to say like one thing before we kind of start talking about this. So, can I do this in red? This whole chapter is dealing with the fine tuning of the universe. And so the way he's doing this is kind of like an end run around all the other objections, right? But you have to remember that like all these issues are all multiplied together, right? So if we think about like the fact that we're here and we're even talking and thinking about this stuff, right? We would have to say, okay, what are the factors that allow us to be here, right? So like we think about consciousness and that sort of stuff. Like how can matter be about something? Like how could I have intentionality if I'm just the material in me? That's a very difficult thing to understand. So you have that sort of stuff. But even if I don't write that on the board, at the basic level, you can think about all the factors that are necessary to go from non-living to living, right? You know what I'm saying? Like how do we get from non-living to living? So if we go from there's all kinds of factors that are necessary, right? But then, in order to even have the components to make that thing possible, then we have to think about all the factors necessary for life to even be possible on the planet Earth, right? I mean, I think about this all the time. How like sensitive we are. I mean, there's a very small range of temperature that we can function in. Like even with the wind the other day. Imagine if the wind was like that all the time, how miserable it would be. But think about like if we didn't have the moon, our planet would wobble. And you'd have massive temperature variations. Because think about like the Earth is tilted, right? So if this is the sun, the Earth is tilted on its axis and we spin around every day, but that tilt stays the same. So if this is winter time, so the southern hemisphere is tilted towards the sun, so it's warm down south, and then we get to like spring and summer, and then we're tilted. But just that little tilt is the difference between summer and winter temperatures, which is like huge for us. I mean, think about 90 degrees versus 15 degrees in the winter. And think about if that happened all the time. Like you couldn't live here because like we wouldn't be able to feed ourselves. The plants wouldn't grow, they would all die. Like, so think about that, that's just the moon. And then you have the atmosphere, plate tectonics, and liquid water, and all these other factors. And the sun has to be the right size, the right stage of its life, and we have to be the right distance from it. If we didn't have Jupiter, if we didn't have all these other things, right? And even then, if we weren't in the right part of our galaxy, because there's a habitable, you ever watch the movie The Privileged Planet? That's homework. You should do that. It's on YouTube. It's called The Privileged Planet.
Is it about like how fine-tuned everything is?
Yeah, and it's the whole idea of the video is that we are in just the right location with just the right factors to be able to see that we are in just the right location to be able to have all these factors to be here. Right? Like even within the galaxy, we're in between two of the spiral arms of the Milky Way galaxy in just the right spot, where not only is it not likely that we're going to get hit by stuff, but we can see out of the galaxy into the rest of deep space.
Most places you can't see.
Well, if you're like in one of those arms of the Milky Way, there's so much stuff that's hard to get like to see out. But like we're kind of like in a clear spot where we can see out into the rest of space.
Are there videos of any planets like ever colliding with each other and stuff like that?
Not planets. No. I mean, think about like
or like stars or stuff.
Imagine like
they have like those there are stars that go into each other, and there's even galaxies that they can see that are like running into each other.
Wow.
Imagine if like a gas giant ran into like a solid planet and just go like.
Oh yeah.
But anyway, the point that I want to see is like, so you have that, and then you have for life on Earth, like, I mean, even to have the Earth, and then you have like the stuff that we're talking about, which is the universe itself being life permitting. So like all the factors that we're going to talk about, then you'd have to multiply them by the probability of all these factors. Then you'd have to multiply it by the probability of all these factors. And when they're talking about some of these things in this chapter, they talk about the probability that we are in a low entropy universe. It says Roger Penrose has calculated the odds of that low entropy state existing by chance alone is on the order of 10 to the 10 to the 123rd. All right. Which is like so big that I can't even explain it to you. Like that, and they give you, if you read this, do you guys read any of this stuff? They talk about the number of seconds in the entire history of the universe. If you say the universe is like 14 trillion years old, it's 10 to the 17. Right? Did you get that? So 10 to the 17 is 14 trillion seconds. So he's saying that the odds, just the odds that we're in this low, you know what low entropy means? I should clarify these terms, right? So low entropy means like that's the second law, that we're in a universe that's like has all this usable energy. So the odds that we are in a universe that's like that, he's saying is 10 to the 10 to the 123rd. Which is like, and you're like, you know, like if you watch politics and stuff, they talk about like, oh, we're going to spend $1 trillion on this. Do you ever see like how long $1 trillion is if you did it in seconds?
Yeah,
That's
yeah, it's like 429 years or something ridiculous.
No.
Oh, it's 429,000 years. No, it's something ridiculous because I remember 1 million seconds is 4 days and 1 billion seconds is 32 years. And 1 trillion seconds, it's a large number.
I'm just doing this.
How big is $1 trillion land?
Wow.
$1 trillion. Oh my
It's
god.
oh my gosh. Oh wow. Oh, I like these ones.
You've seen these
too. Like comparisons.
Good grammar and spelling are important.
Really? Is it I knew it! Yeah.
Nathan doesn't agree. That's not Nathan's style.
You're terrible.
He accepts it.
Banana.
Yeah.
Oh.
That's about right. That's about how big it should be spots. Yeah. No, that's only 10 million.
10 billion.
10 million?
Oh yeah, wait, 10 billion.
100 billion. 1
1
trillion.
trillion.
Look at that little one down there.
It's
That's
bigger
a
than the
million.
Coliseum. It's bigger than the White House.
Of $1 bills, right?
Wow.
Oh my gosh.
The fourth one down, that's a million. That's the difference between a
That's
trillion and a
That's a
million.
tight stack too.
No, wait, no,
That is a tight
That's
stack.
the one down.
If
No,
the wind blows.
Sorry,
This
that's
one
a billion. That little one down there is a
Yeah.
billion.
That's like
No,
it's bigger
that's
than
like
the
a billion.
Coliseum.
If the
wind
It's
blows,
two-
just
it's 1 trillion is 2.
How do they know they
Coliseums.
got the dimensions right on?
I know, right?
I know.
They just count every bill.
They just actually stack up $1 trillion bills.
How long would it take to count to 1 trillion? Oh my goodness.
Oh my god.
1 trillion. That's how long it would
It'd
take.
take 1 trillion seconds.
If you count a number of seconds.
Science. In this video, I'd like to talk about how long it would take to count to certain big numbers, to give you a little idea how big some numbers are. To keep it in perspective, we'll be counting money. It takes about a second to count a dollar bill, so we'll be counting dollar bills. We'll be counting 1,000, then 1,000,000, and then someone like Bill Gates who makes 1 billion, and then 1 trillion. Let's review a couple of large numbers. 1 million has 6 zeros, 1 billion has 9 zeros, and 1 trillion has 12 zeros. Let's start with counting $1,000. There's 60 seconds in a minute. 1,000 divided by 60 seconds is 16.6 minutes. Not bad. Now let's have a big pay raise and jump to 1 million. We have 3,600 seconds in an hour, and there were 24 hours in a day. You get 86,400 seconds in a day, and 1 million divided by 86,400 equals 11.
I used to offer kids in my class, sometimes I'd be like, all right, we would talk about like numbers and stuff, and I'd say, all right, I'll tell you what, if you can write out the words like O-N-E, T-W-O, T-H-R-E-E, you just write them out. I know I didn't even say that. I said, just write the number. I said, just write number. If you get a number from 1 to 1 million, I'd do it on like a Friday. So if you could do it from 1 to 1 million and have it to me by Monday, I'll give you an A for the whole year. And they're like, oh, I'm on that. I'll take that. I'm on that. And I'm like, you can't do it. They're like, oh yeah, I can. I'm like, no, you can't. It's impossible. Like, oh, all right, watch me. And they start going. But like it says here, even if you did one number per second, it would take you 11 and a half days to do it. So
You know what?
My hands would hurt.
You know what you should have done? What you should have done is had like 3 different people work on it, and then one person turns it in.
Yeah.
7 days. So if you made $1 million, it would take you 11 straight days, counting 24 hours a day to count your money. Now we're going to move into the Bill Gates era and have $1 billion. We're going to start at 86,400 seconds in a day. So if you take that, so then if we take 1 billion and divide it by the number of seconds in a day, we get 11,574 days. Divide that by 365 days and it gives you 31.17 years. So it would take Bill Gates a while to count.
Now this is what I'm showing you.
Last I saw,
Watch the difference between $1 billion and $1 trillion.
And now let's get an idea of what a trillion
Oh my.
Let's take it one more step. We'll take 86,400 seconds.
I was close. I said 45,000 years.
In a year. Now we will take a trillion and divide it by the amount of seconds in a year, and you get 31,709.9 years. That's a long time to be counting your money. Hopefully this will give you a little idea of how large.
All right. So, all right, with that being said, have you got? I'll show you the fine-tuning video for this.
And if you were smart enough, you would make a program that would count it for you, so then you could turn it in.
That would probably still take
I know.
at least.
Well, there's computers that are doing the digital.
Well, if you're doing it fast enough.
So before we do this, if you guys haven't read this, read this chapter for next time. But this is kind of like all the videos we've been watching is a summary of the chapters.
Did you know that the average adult has 5 to 20 pounds of toxic poop in their body at any given moment? Seems crazy, right?
What a great ad.
Okay.
We're gonna have to go
Those
to
are the ads
ad-free.
for people who aren't signed in.
You can get an ad blocker.
The very structure of our universe is determined by these numbers. These are the fundamental constants and quantities of the universe. Scientists have come to the shocking realization that each of these numbers has been carefully done to an astonishingly precise value, a value that falls in an exceedingly narrow, light-permitting range. If any one of these numbers were altered by even a hair's breadth, no physical, interactive life of any kind could exist anywhere. There'd be no stars, no life, no planets, no chemistry. Consider gravity, for example. The force of gravity is determined by the gravitational constant. If this constant varied by just 1 in 10 to the 60th parts, none of us would exist. To understand how exceedingly narrow this life-permitting range is, imagine a dial divided into 10 to the 60th increments. To get a handle on how many tiny points on the dial this is, compare it to the number of cells in your body, or the number of seconds that have ticked by since time began. If the gravitational constant had been out of tune by just one of these infinitesimally small increments, the universe would either have expanded and thinned out so rapidly that no stars could form and life couldn't exist.
I like
Or it would have collapsed back on itself with the same result. No stars, no planets, and no life. Or consider the expansion rate of the universe. This is driven by the cosmological constant. A change in its value by a mere 1 part in 10 to the 120th parts would cause the universe to expand too rapidly or too slowly. In either case, the universe would again be life prohibiting. Or another example of fine-tuning. If the mass and energy of the early universe were not evenly distributed to an incomprehensible precision of 1 part in 10 to the 10 to the 123rd, the universe would be hostile to life of any kind. The fact is, our universe permits physical, interactive life only because these, and many other numbers, have been independently and exquisitely
Oh
balanced.
my goodness. I've done that before.
Wherever physicists look, they see examples of fine-tuning. The remarkable fact is that the values of these numbers seem to have been very finely adjusted to make possible the development of life. If anyone claims not to be surprised by the special features that the universe has, he's hiding his head in the sand. These special features are surprising and unlikely. What is the best explanation for this astounding phenomenon? There are three live options. The fine-tuning of the universe is due to either physical necessity, chance, or design. Which of these options is the most plausible? According to this alternative, the universe must be light permitting. The precise values of these constants and quantities could not be otherwise. But is this plausible? Is a life prohibiting universe impossible? Far from it. It's not only possible, it's far more likely than a life permitting universe. The constants and quantities are not determined by the laws of nature. There's no reason or evidence to suggest that fine-tuning is necessary. How about chance? Did we just get really lucky? No. The probabilities involved are so ridiculously remote as to put the fine-tuning well beyond the reach of chance. So in an effort to keep this option alive, some have gone beyond empirical science and opted for a more speculative approach, known as the multiverse. They imagine a universe generator that cranks out such a vast number of universes that, odds are, life-permitting universes will eventually pop out. However, there's no scientific evidence for the existence of this multiverse. It cannot be detected, observed, measured, or proved. And the universe generator itself would require an enormous amount of fine-tuning. Furthermore, small patches of order are far more probable than big ones. So the most probable observable universe would be a small one, inhabited by a single, simple observer. But what we actually observe is the very thing that we should least expect: a vast, spectacularly complex, highly ordered universe, inhabited by billions of other observers. So even if the multiverse existed, which is a moot point, it wouldn't do anything to explain the fine-tuning. Given the implausibility of physical necessity or chance, the best explanation for why the universe is fine-tuned for life may very well be it was designed that way.
Why are there birds in space?
A common sense interpretation of the facts suggests that a super intellect monkeyed with physics, and that there are no blind forces worth speaking about in nature. The numbers one calculates from the facts seem to me so overwhelming as to put this conclusion almost beyond question. There is for me powerful evidence that there is something going on behind it all. It seems as though somebody has fine-tuned nature's numbers to make the universe. The impression of design is overwhelming. The heavens declare the glory of God. The skies proclaim the work of his hands. Day after day they pour forth speech. Night after night they reveal knowledge.
All right, so we'll stop there today.